Welcome to The Explainer. So, have you ever looked at a perfectly constructed metal electrical cabinet, or maybe an HVAC duct, and wondered how on earth do manufacturers get those exact holes and clean foldable corners without just totally warping the solid metal? Well, today we are unpacking the hidden industrial engineering that literally shapes the world around us. We're talking metal punching and notching.
Here is our roadmap for the explainer today. We're going to systematically break this complex machinery down. First, punching versus notching basics. Then we'll meet the machines, check out the tools of the trade, look at some real-world applications, and finally wrap up with safety, maintenance, and costs. All right, part one, punching versus notching basics, the core dichotomy. Let's dive right in. Now, before we separate the two, we really have to understand the fundamental action at play here, which is shearing. Unlike drilling, which, slowly grinds away metal and leaves behind this totally messy pile of metal chips, shearing actually cuts the material in a single, powerful stroke using punch and die force. Think of it exactly like a massive, heavy-duty industrial cookie cutter. Just bam! One stroke, and you have a perfect, clean shape. So the really crucial point here is how we apply that shearing force. Metal punching, that's all about the inside. We're talking internal holes, slots, and cutouts. Metal notching, on the other hand, works the perimeter. It removes material from the outside edges or the corners of the sheet. And you might be wondering, why? Well, it creates a clean clearance so that flat piece of metal can be perfectly folded or joined into a three-dimensional shape. But you don't just hack away at the metal. There is a highly structured, step-by-step workflow required to get that perfect notch right before the bending or welding phase. First, you mark or program the exact location. Then, you precisely position the sheet, strictly clamp down the material so it absolutely won't budge, actually cut the notch, and finally carefully inspect the edge for any burrs. It's a rigorous process, for sure. Moving on to part two, let's see how this builds into the machines. Meet the heavy-hitting hardware. There are three real workhorses on the factory floor here. First up, hydraulic machines. These deliver immense smooth force, making them the go-to for thick plates and solid busbars. Then you've got CNC turret machines. These use computer-controlled positioning and rotating turrets filled with tools for extreme automated repetition. And finally, the ironworker. This is basically the ultimate all-in-one utility player, incredibly versatile for profile and angle cutting. The crucial takeaway here is that when high-volume shops need rapid, automated precision, they lean heavily on those CNC turret machines. The advantages are just massive. We're talking reduced manual layout, highly repeatable hole positioning, and a significantly easier CAD/CAM workflow. The machine just reads the digital file and cranks out complex patterns much faster with way lower operator dependency. It is literally the pinnacle of high-speed manufacturing. All right, part three, tools of the trade. Anatomy of the cut. Now, what's really interesting here is when we zoom all the way in to look at the microscopic precision of the tools doing the actual work. You have the punch, which is the upper tool physically cutting the shape. Below that is the die, which supports the material and receives the punch. Crucially, there's the stripper. This mechanism physically yanks the cut material off the punch after the stroke. And finally, the hold-down system, keeping that entire sheet totally stable while literally tons of force are applied. But here is the absolute secret to a perfect cut: die clearance. The die opening actually isn't the exact same size as the punch. It's just a tiny bit larger. This critical microscopic space is calculated precisely based on the material's thickness. Because if that die clearance is off, the shearing action fails and the required machine force shoots straight through the roof. It is totally essential. So what happens when things go wrong? Let's walk through this uh-oh sequence. If your die clearance is wrong or your punch is worn out, you'll see defects like an excessive burr, just a totally rough edge. Or you might get something called slug pulling, where poor stripping causes the waste piece to stick right to the tool. You might even see cracking if the material is too hard for the clearance you set. The fix? It always comes down to correcting your tooling and adjusting that clearance. Next up, part four, real-world applications, the invisible engineering. This brilliantly illustrates how these heavy industrial processes create the perfectly stamped structures that are literally all around us. Think about the perfectly folded corners on the HVAC ductwork pushing air into the room you're in right now, or the flawless button panels inside an elevator. Even the sturdy enclosure doors guarding electrical power systems. Every single one of these relies on exact punching and notching before they can be bent and assembled.
And it gets even more specialized in the electrical world. Tucked away inside those massive industrial switchgears are copper and aluminum busbars carrying super heavy electrical currents. Processing these conductive bars requires highly specialized notching machines to guarantee perfect bendability and, crucially, safe electrical clearances within the cabinet layout. Small dimensional errors here, they could be absolutely disastrous.
Which brings us to our final section, Part 5, Safety, Maintenance, and Costs, the bottom line.
Let's shift gears a bit to talk about the human reality of running these machines. Safety during these operations is absolutely non-negotiable because, remember, we are dealing with immense shearing forces. We're talking strict OSHA standard compliance, things like point of operation guarding to protect the cutting zone, and two-hand controls so an operator physically cannot have a hand near the punch when it fires. Hand-feeding tools are simply never a substitute for proper guards.
And keeping this equipment maintained is just as critical as running it safely. Routine maintenance like lubricating moving parts, checking seals, and keeping fresh hydraulic oil, that isn't just a suggestion. It is literally the only way to guarantee consistent notch quality. Plus, keeping tools sharpened prevents catastrophic failures and significantly extends the life of these massive investments.
So, let's pivot from the factory floor over to the accounting department. What is the true cost of punching and notching?
Well, the purchase price of the machine is really just the beginning. Calculating the true return on investment means breaking down these hidden business expenses. You've got constant tooling needs, punches, dies, custom blades. You have to budget for maintenance, operational costs like labor and energy, and of course, the inevitable downtime. But here's the thing. When a shop weighs these expenses against the massive time savings and reduced errors gained over slower manual processes, the numbers really do make owning these machines incredibly cost-effective for large production volumes.
We've covered a lot of ground in this explainer today, from the raw power of hydraulic shearing to the micro-calculations of die clearance. So, I'll leave you with this provocative thought. The next time you open a metal fuse box or step into an elevator, will you notice the precision of the invisible, stamped metal world around you? Thanks for joining me on this explainer, and keep looking for the blueprint behind the build.